Okay, so let us come to the very last part of our vector chapter already. So for today's learning outcome, we need to learn how to find the perpendicular distance from a point to a line by using the vector method. All right, so perpendicular distance we also call it as the shortest distance. Shortest distance, shortest distance. All right, so from a point to a line, that means you are having a line, and then they want you to find the point to the line's distance. So this is what we call as perpendicular distance. Okay, all right. So in our notes we provide three different methods here. All right, so two of them actually involve dot product, and then another one involve the cross product lah. So it depends on which method you like the most. All right, so all the methods will give you the same answer definitely. For me myself, I usually focus on the first method. All right, so it depends on which one you prefer more lah. First method, although it looks like a bit longer the steps, but to me I can see what am I doing very clearly. All right, so for method number 2 and method number 3, using the cross product and also using the Pythagoras theorem, generally, right, if you want to get the idea from the formula itself straight away, it's not easy. Okay, the formula is derived actually from a lot of other formulas that only they come to this as conclusion. All right, so you might not able to know why this formula is actually the shortest distance. Okay, so it depends on you lah. So for me, I will still focus on method number 1, and then you can try to understand and figure out yourself for method 2 and 3. For me, I will still explain to you all the methods here, and I will show you also all the 3 methods here. All right, so you can choose on your own after you go through with the 3 methods. All right. Okay, so let's have a look for the first method first. Okay, so this is what we have for the first method. Okay, first of all, you need to know in the question itself, what are they going to give you? So let's say they give you a line. L is the line passing through A and B, and the shortest distance, perpendicular distance from a point C to L can be found by the following methods. So you can see that in the question itself, usually they already give you the line equation, the vector equation, okay, for the line AB, and then they also will give you the point C. All right, so this is the coordinate that they will give you usually. Okay, so now how am I going to find out the shortest distance here? Okay, so first of all, you look at method number 1. So method number 1, I call it as using dot product. Actually, the third method also we are going to use the dot product, just that they top up with the Pythagoras theorem. So I named that as Pythagoras theorem. Okay, so this one is dot product. So first of all, what we need to do is like the position vector foot of perpendicular D, OD is equals to OA plus TAB. Okay, so I don't know whether you still remember or not, at the very beginning of the vector equation part, when I asked you all to find out the vector equation, right? I told you actually when I want to find out a coordinate for a point on the line, okay, you substitute a value into the t, right, to get a coordinate. But now, because I don't know what's the coordinate for D, I will let it equals to the vector equation. So this is actually the vector equation formula for the line. Okay, just that now I assume that it is the coordinate of OD, the position vector of D. All right, so the D must be the foot of perpendicular. All right, so if you look at this one, this is your passing point. According to the definition of our vector equation, right, this is passing point. And then what is the AB here? So the AB will be the direction of the line. Okay, so AB will be the direction of the line, where you can also assume that AB is equals to P. All right, if you understand like this method. Okay, so OD, the first step is you let OD equals to OA plus TAB. Then the second step is you try to find the vector CD. Okay, so why you try to find the vector CD is because of eventually you want to find this length, correct or not? So I try to find out the vector CD first. So this vector CD actually it consists of T in your vector CD, consists of T. All right, the value of T that you don't know. Okay, and the third step is find the value t by using the result cd.ab equals to 0. So I think very obvious also. Since you know that the direction CD and also the direction for AB, they are perpendicular to each other, right? So you can actually use the result CD.AB equals to 0. Then from there, you find the value of t, and eventually you try to substitute the value of t into the CD, and then after that, you find the magnitude or the length for the CD. Okay, so this is how we find the shortest distance for a particular point through a line. All right, so this is the first method that we have. Okay, so some students, they actually don't like it because they found that it's like there are many steps. All right, but to me, I can see very clearly what am I doing actually. So I prefer this method more compared to other methods. All right, so I will show you example how to solve the question by using method number 1 first. Okay, so we can discuss this by using example 20. Okay, so example 20, this is the question. We are having a point. So this point, in this example, we name it as point VP lah. So if you want to compare it to the method that we use, so that is point C in our formula. Okay, and then the line has the vector equation for this one. Okay, so if you want to compare, this is OA. Okay, so sorry, wait. So this is OA. And then this is your AB, or the direction of the line. Okay, right. So first they want you to find the perpendicular distance from P to L. Okay, so first of all, maybe if you want, you can draw a line. So this is a line. This is A. Then maybe this is B or whatsoever. And then this is the foot of perpendicular. So maybe the foot of perpendicular, you still want to use D. Okay, so this is P, which is -1, 4, and 11. All right, so this is actually the distance that you want to find. Okay, all right. So I try to draw it out like this so that you can see clearer. Okay, so first you can try to find the foot of perpendicular. Okay, so first step, so you find the position vector for the foot of perpendicular. Okay, so this is your first step. But of course, in exam, you don't need to write out this one. Maybe I don't write out also. Okay, so just to let you know, this is the position vector for the foot of perpendicular OD. It will be equals to the vector equation originally, just that you don't know the value of lambda now. Okay, so instead of using lambda, if you want, you can change it become t, because maybe t is a particular value for this OD. Right, so you're having 1 plus 2t, and then 3 plus t, and also -4 plus 3t. All right, so this is what we have for OD, the foot of perpendicular position vector. Okay, so maybe for me, I will label this as my first step lah. Step number 1, just to let you refer to the method that I showed you earlier in the notes. Okay, and after that, what is the second step here? You need to find out the vector CD. So for us, we need to find out the vector PD. Okay, either you want to use PD or DP, also no problem lah. So what is PD here? So PD means PO plus OD. Okay, so I hope that you know how to get a PO. So PO is 1, -4, and -11. Then plus OD. So OD is 1 plus 2t, 3 plus t, -4 plus 3t. Okay, so if I continue further from here, what will I get? So when you try to simplify it, PO plus OD, your PD should be equals to 2 plus 2t, and then -1 plus t, and also -15 plus 3t. Okay, so this is my second step. All right, so you find out the vector equation for, oh sorry, you find the vector for PD already. Then now I proceed to the third step. So third step, you will see that since the PD, okay, since the PD and also the AB are perpendicular to each other, right? So we will try to put PD dot AB equals to 0 because they are perpendicular to each other. Or you can say AB as the direction of the line. All right, so PD is 2 plus 2t, then negative 1 plus t, and then negative 15 plus 3t dot AB. So AB is the direction of the line, which is 2, 1, and negative 3. So you let it equals to 0. All right, so you can try to apply the dot product that you learned before, and you try to solve for the t. So eventually you should get t equals to 3. Okay, so once you get t equals to 3 already, then we can get to point number 4, the step number 4. So the step number 4 will be you substitute the value t equals to 3 into the PD. And after that, you try to find the magnitude of PD. All right, so once you substitute PD, t equals to 3 into the PD, right, you should get 8, and then 2, and negative 6. So this is a vector PD, and if you want to know the length or the magnitude, you need to find out the modulus, right? So if you continue with the modulus part, then you are having 8 square plus 2 square plus negative 6 square. So eventually, I believe that you should be able to get square root 104. All right, so this is how we actually try to find the shortest distance between a point and also a line. Okay, by using the very first method here, I call it as dot product method. Okay, can or not? So if let's say no problem, you can pause the video here and then you try the next example by using this method first to see whether you really understand or not. All right, but to me, I think it is clear enough because I can actually know what am I doing throughout all the steps here. Okay, I can see very clearly what am I doing to get the answer. All right. Okay, so you can pause the video, try first, and then you continue with example. You continue with the video. All right. So I'm looking at I'm trying to discuss with you example 21. Okay, I will show you how to do it. Okay, so this question itself is longer. Of course, they already tell you all the information here. So this diagram shows 3 points, A, B, and C. And then the position vector with respect to the origin O are given by OA, OB, OC. They give you all the position vector. Then the point D lies on BC between B and C and is such that CD equals to 2 dB. So by using this information, please try to find out what is the position vector of D. All right, so this is a question which is quite simple. I will just give you the final answer. So the OD is equals to 1, 2, 2. So this is the answer for OD. All right, so how to start to find out the OD? Then you use this CD equals to 2 dB. All right, so if let's say CD equals to 2 dB, then you just apply the addition of the vector lah. So means CO plus OD equals to 2, and then DO plus OB. Then you move all the vector here and there, you can get the answer. So to me, this is a very simple question. I'm not going to discuss it. Okay, then now we continue to part number 3. They want you to show that the length of perpendicular from A to OD is this one. So they already give you the answer, actually. Okay, so maybe you can imagine. So this is the line. And this is a line BC. Okay, so now the symbol might be got a bit problem already lah. Okay. Oh, sorry. So they are asking for, sorry, not BC. They want to find the perpendicular distance from A to OD. All right, so this is the perpendicular distance that they want to find out. All right, so which is 90 degree. So this is the distance for the line OD. Okay, so now you can label this point first, the foot of perpendicular. Maybe you can label it as any value, any letter that you like now. So maybe for me, I put it as H in this case. All right, so first of all, you need to write out the vector equation. Vector equation of OD. What is the vector equation of the line OD? Do you still remember? So it should be R equals to passing point. So for this particular passing point, the passing point is 0, 0, 0, right? So you can use 0, 0, 0 as a passing point. Okay, plus T direction of the line. So the direction of the line will be OD lah. Okay, so the direction of the line will be OD. And just now you already found that OD is 1, 2, 2. Okay, so this is the vector equation of OD. It is not wrong if you put this value as 1, 2, 2 because D is also one of the passing point on the line, right? So if you put 1, 2, 2 plus T bracket 1, 2, 2, also no problem. They are the same line actually. Okay, so this is the first step. Then I need to find out the foot of perpendicular vector, right? Position vector. So I will also write it like this. So what is OH? So OH is equals to T 2t and also 2t. So this is my first step. I write out the vector equation for the foot of perpendicular. Okay, so second step, I need to find out AH. All right, so what is AH here? So AH means AO plus OH. Okay, so if you try to continue from here, should be no problem for you to get negative 2 plus t 1 plus 2t and then negative 2 plus 2t. So this is the step number 2. Find out the vector AH. Okay. All right. So maybe you will ask, where's the AA? Is this one? OA is this. So AO should be all opposite side. All right. Then now we continue further to the third step. Okay. So third step, by using the definition that AH dot OD is equals to 0 because of these two vectors are perpendicular to each other, right? So AH dot DO equals to 0. All right, so you have the AH here, right? Then you have the OD or DO. So OD is this one. Okay, so if you continue from here, for this question, you should get T equals to 4 over 9. It is a fraction, although it doesn't look nice for fraction, but this is the correct answer. And after that, if you continue to part number 4, step number 4 is you need to substitute the t equals to 4 over 9 into the AH vector. So if you substitute 4 over 9 into AH, you'll get some very weird values, but it's okay. Negative 14 over 9, 17 over 9, and also negative 10 over 9. All right, then after that you try to figure out the magnitude of AH. I think very easily you will get the answer. So this one will be negative 14 over 9 square plus 17 over 9 square plus negative 10 over 9 square. Okay, so you should get the correct answer, which is 1 over 3 square root 65. So these are the steps for method number 1. Okay, so I hope that you roughly have the idea what we are doing here. So we are having 4 steps here. So I hope that you can see very clearly from steps to steps what are you doing actually. So for me, I don't like to purely memorize the formula. So this is a better way for me. Alright, so if let's say you find that this method you don't like, maybe you can refer to the next video that we discuss method number 2, or maybe the next video that we discuss method number 3. Okay.